3D Printing Today, show number 384. Foam Nozzle. DIY LIDAR Part 3. Toolchanger advice.
Welcome back to 3D Printing Today, the podcast about all aspects of 3D printing. Hobby, professional, industrial, doesn't matter. We cover it all. This is Andy Cohen, and I'm here live after a year of doing it remotely. We are together live with Mr. Whitney Potter.
How you doing, Andy?
Dude, it's so good to see you again.
It is definitely good to be back.
It is. Both of us are vaccinated. Whitney got the vaccine early because Whitney does emergency rescue work. And I got my second shot 2 weeks ago. So today's my immunity day.
There you go.
It's Cinco de Mayo, so we're going to go out and have some margaritas later.
Okay, good luck.
And we hope all of you do the right thing and get the vaccine. Do it for you. Do it for the folks around you. Do it for people you don't even know. Just do it. It's a needle in your arm, and you're not a 5-year-old any longer. And yeah, they won't give you a lollipop for it, but go get the vaccine.
It's okay. 3D print yourself a lollipop
3D
if you
print
need
yourself
one.
a lollipop. Yeah. Let's see. So we do have some interesting news today. All year long, we've been hearing about these special purpose acquisition companies that pool together a huge pile of money and team up with another company with an established product line and established flow and channels and do something with that company that's kind of exciting. We've seen it happen with Markforged and a couple of other companies. Today, we're seeing it happening with Shapeways. Pretty exciting. They're merging with the Galileo Acquisition Corp, which is another form of special purpose acquisition company. Their combined evaluation, the value of these two companies together is $605 million.
Right. So basically you've got Shapeways, and then you've got another company which just exists as a piggy bank.
Yeah. And that piggy bank's expecting Shapeways to do great things, making them more money. I hope they're right, because I think the assumption a lot of these companies are making is that the economy and the potential for business is going to take off like a rocket.
Sure.
So far, we are seeing indications that is going to be the case. However, the supply chains are still extremely disrupted. Things like electronic chips, processing chips are affecting the auto industry. Gasoline, they're having trouble delivery because they don't have the drivers to drive the trucks, which requires a special license. We're seeing issues with the food industry. We're hearing stories about China buying up all the futures so they could feed their swine herds. All sorts of weird stories about how things are going to get very expensive very quickly. What we haven't seen yet are the costs for filament to take off. I'm not seeing that yet.
Yeah. Well, who knows if there's a disruption in supply chain of some plastic widget, then maybe 3D printing could just jump in there and solve that problem.
Well, we saw that with the pandemic a year ago when PPE was a problem.
Yeah.
We were making our own masks and visor holders and all sorts of things. It was the time to have a 3D printer. I think 3D printing we're going to see more and more of. For sure, it's indicative of what's happening with these special purpose acquisition companies. In the meantime, Whitney, what's on the docket for today's show? Show number 384.
Well, we start out talking about a foam nozzle.
You give us part 2 of your do-it-yourself LIDAR scanner.
And then you give us some Toolchanger advice.
Oh boy, let's do it.
So have you ever used the spray foam stuff that you buy at like the home center? Comes in a can. The most common brand in North America is called Great Stuff.
It's that stuff you stick into like gaps in your wall and it kind of fills it in. Yeah.
Right. It's a DuPont product, the one that we use, but all the big chemical companies make their own. But I like Great Stuff because it works. Not only does it work for filling gaps, but it's also a really good glue that a lot of people don't recognize this. But years ago, I was working on a building down in Florida that we had steel. The ceilings were basically steel with poured concrete on top. This was a hurricane-resistant structure. But we had to figure out some way to insulate these steel ceilings. And the solution was to get 4-inch thick EPS foam sheets, so 4x8 sheets, 4 inches thick, and then glue them to the ceiling. And we went through a number of different glues from manufacturers that were incredibly expensive, some of them, and none of them worked. And then we stumbled on Great Stuff, and Great Stuff, you just squirt it out onto the surface, squish them together, and hold it for about 5 minutes, and it's set. And that building has there was no other surface, fasteners or anything holding those foam panels up. And it's been about 25 years now in Florida, and the foam sheets are still there. So it is a good adhesive solution, especially because there you have, a 4-inch thick EPS foam sheet weighs something. Mm-hmm. It's probably 20, 30 pounds of foam there, and it sticks them up just beautifully. So I'm working on building out my camper van and want to put in some insulation. And so what's the first thing I think about? But Great Stuff, right? Because it's not only is it an insulation, but also works as a glue. So I'm sort of doing a combination of polyiso foam sheets, which are the best insulating foam you can get, but they're quite rigid and don't conform well to curves. You can't bend them around things. So I'm sort of gluing them, cutting them up into chunks and gluing them in places that I can, fit them using this Great Stuff foam. But one of the problems with it is that when you spray it, it comes out of the can and it comes out in this one little bead of foam that squirts out, kind of a snake that goes squiggling all over the place. It's really good if you have a crack because you can stick that nozzle in the crack and go swoosh and fill up the crack. Right. But if you want to cover a surface with it, it's terrible because the stuff doesn't stick where you want it to. It kind of flies around and eventually lands somewhere. It's
because you're using it as a use case that it was not originally intended for.
Right. Yeah. But it's a use case that's actually pretty common. There's a lot. I'm not the only person who's figured out that it's a great glue. A lot of people use it like that, particularly with foam. It's the best glue for gluing foam to foam because it doesn't melt the foam and it sets almost instantly. So anyway, I was thinking about it and was going, yeah, I wonder if anybody sells a nozzle for it. And I'm like, wait a minute. Sells? Why do I need to buy something? I can just make it. So I went in and fired up Fusion 360. Now, this is one of the rare cases where I've been printing something lately that I didn't actually start preheating the printer before I started designing it, because I knew this was going to be a little bit more complicated. Still, it was probably about a 20-minute design process instead of about a 3-minute design process, which is what most parts on a Fusion 360 are. But in 20 minutes, I had a nicely designed nozzle that goes on the spray can, and then basically spreads it out like kind of a fan pattern. And it has little passages inside the nozzle that direct the foam and spread the foam out. And about a half hour after I finished designing it, I had one printed on the printer to test it out, and it works brilliantly. In fact, it worked so well that I went back and made another version of it that was a little bit wider for some applications. And I haven't tested it yet, but I made a super wide version of it. And the sweet thing about it is that Fusion 360, you design it once, and then you can go back in and tweak it to whatever dimensions you want. And of course now, you can tell you can tell I'm kind of a nerdy engineer at heart, because I noticed the first version of it split the foam into 4 different channels. And I remember designing it thinking, well, the ones on the far outside have got to go further, right? So I want to have a larger diameter, so I have less pipe flow loss as the foam is getting out to there, so I have an even dispersion of it. And then after that one, I'm like, okay, well, I got to go tweak it a little bit, because I'm still, the beads of foam on the far outside are not quite as big as the ones in the middle. So, and of course, it being Fusion 360, I can go back and drag one dot, and it changes the size of those ducts on both sides of it. It's a brilliant program, and if you set up your model right, it is so easy to change and maintain things. So anyways, they are disposable parts. It's kind of like, the nozzle on the spray can. It's
you can only
once
use
the
it
foam
once.
sets. Yeah, you only use it once. But they take a half hour to print, so it's no biggie. If I had a belt printer, I would probably just print a dozen of them at a time.
Send me the STL and I'll print a bunch for you.
Okay.
By the way, that's a perfect candidate for Thingiverse. I sure hope you're going to post that.
I will. I just the problem is getting a photo of it in use, because when I'm using it, I've got gloves on and I've got foam everywhere, and I don't want to be touching a camera.
Well, that's what your son is for.
Yeah. Well, try telling him that. So I've been working for the last couple of months on and off on my DIY 3D LIDAR scanner, right? So I'm taking a 2D LIDAR scanner, which is the little spinning LIDAR unit that you get that's designed to go on a robot, basically. And I'm turning it around in its own axis and recording data while I do that, so to make a 3D scanner out of it. My first versions of it, I just had literally the first one I did, I attached the scanner to a hobby servo and used that to spin it, although soon realized that the hobby servo wasn't really accurate enough for what I wanted to do. I couldn't address enough angular resolution with it. So I switched over to using a stepper motor, and a stepper motor using a micro stepper driver, so I'm driving to 256ths of a step, although they're not really accurate to a single step. But if you get down to 5 or 10 steps, they're pretty accurate. And so I've been having good luck with that. A lot more resolution than I really need in terms of that angular accuracy. But I have come up with a few interesting issues. I've been using it lately to scan the interior of the van that I'm building out as a camper. And that's a good one because a van is not perfectly square. It's got a lot of curves, but it is very mechanically precise. It came off of a production line, right? And so the first scan I got, I looked and I was like, that's funny. That van looks kind of curved. And that was when I realized that my stepper motor was actually dropping steps somewhere along the way.
That's unfortunate.
Yeah, it's if your stepper doesn't move exactly as you expect it to, then you're collecting data, but you are not interpreting where those points actually are, right?
Yeah.
Because we're basically interpolating the angle that the scanner is set at based on where we think it is, based on sort of dead reckoning of the stepper motor from its start point. This is the same way we do it with 3D printers. It's an open loop control system, but we have no idea if we're actually doing it right. So you have to make sure your stepper motor is very reliable. So I've worked on a couple of different versions of trying to fix that. The other issue, of course, is trying to reduce the amount of amperage that it draws, because the whole thing is battery powered. And if I'm overdriving the stepper motor to get the maximum amount of torque possible, and using my first version of it, I built with a NEMA 17 stepper motor, which was way bigger than it needed. Now I'm down to a NEMA 10. Which seems to be working okay, but it has to be, sort of under perfect optimal circumstances. But it draws like about a quarter of the current that the NEMA 17 was drawing, and since the primary draw on the battery is the stepper motor driver, I can make a lot more scans on a battery than I could before. So the question is, how do you make this thing turn around very accurately? And my first versions of it, I just have, it has a cord that's attached to it, but the whole thing only has to turn 180 degrees. So I basically just have it drag the cord around. But when I got down into the smaller, lighter stepper motors, I think the drag of the cord was actually causing it to drop steps in places. So I said, well, rather than a cord, I could use a slip ring, so the cord is not being dragged around in a circle, and that rotary access is being done with a slip ring. Luckily, you can buy slip rings for about $10. Unbelievable how cheap these things have become. So you can get a 6-conductor slip ring, which is basically a rotary joint with 6 wires that go in the bottom and 6 wires that come up the top, and the whole thing has the ability of rotating 360 degrees while keeping those wires electrically connected. So I tried that, but the problem is the slip ring adds so much mechanical bulk to the device that I didn't really like that solution. So now I mean it worked, but it was really awkward. It made the whole thing very tall because the slip ring added about 1.5 inches of height, and there was no way around that. So now I'm back to another solution, which is actually the solution that the real professional 3D scanners use, and that's just you just make the whole thing, the controller, the battery, the LIDAR, and everything. You make it one unit, and you make the whole unit rotate. And that way you don't have to worry about the slip or anything. But that does require a bigger motor and more power. But I'm sort of figuring out, well, that they've done a lot of research on this, and this is what works for them, and maybe I just should have done that in the first place.
Yeah.
But then I've started looking at different battery, possibilities, and the first one I was working with was just using LiPo batteries, 18650s, which are sort of a standard cell for high-end tactical flashlights. I use them for my caving lights and my SAR lights. Anytime you want like a serious firepower flashlight these days, you're going to be using that format of battery, basically. So I got a bunch of them lying around, and you can very easily buy a battery holder that you snap 2 of them into, and you get about 7 volts out of it, which is perfect, all I need for this application. But then thinking about that, there's a lot of stuff that goes into managing LiPo batteries and managing charging and discharging and stuff. And thinking, well, I don't really want to get into the whole monitoring LiPo battery thing. I just want some solution that's going to handle that. And I happen to notice right next to where I recharge my 18650s, I have another set of chargers. I just have a shelf in my shop with battery chargers on it, basically, for all my different tools. And I noticed that I have these great 18-volt Makita battery packs that I use for all of these cordless tools, that Makita makes. And I've got everything from a string trimmer to a chainsaw. They make incredible variety of things that you can run off them. And I was able to do a little Googling and found on Thingiverse there's actually somebody has made a thing that you order a certain part number that is the actual electrical contacts, and then it pops into this thing that you print, and it makes basically a receiver for the 18-volt battery that you can then draw power off of yourself. So the current state of the project is that I'm actually adapting it so that I can put an 18-volt rechargeable Makita battery. Now they've got, they're taking care of all of the charging. They're taking care of all of the everything that's special about a LiPo battery is taken care of internally. It even has a little built-in battery meter. You can push a button and it tells you what its state of charge is. And they're expensive, but I happen to have a large quantity of them because every time you buy a tool, you get a new one. So that's the current state of the art on this is it's running off of an 18-volt Makita battery.
Sounds good. Well, so is a picture.
We got an email from listener Irumbo Matine. What a wonderful name. I love that name. And I'm assuming but they, I guess, asks, they're making a Toolchanger, the E3D Toolchanger, and want to know if you have any advice on how to dial in Toolchanger and what might trip them up.
Good question. Well, first, resource-wise, obviously, the most important resource for the Toolchanger is E3D, the E3D forum, and thankfully, E3D is intelligent enough to realize that their assembly manual has to be constantly updated, so their assembly manuals are on Dozuki. So if you're thinking about building one of these machines or interested in building your own, you can go see the assembly manual for the Toolchanger, see all the comments that people make to get around issues that they found originally in building the Toolchanger. Specific issues in building a Toolchanger, to be honest, I'm having trouble remembering if there were any real serious issues. If you follow the instructions carefully to the letter, make sure you orient all your parts correctly, you'll be okay. I think the thing that tripped me up the most was with the Titans. I kept putting the Titan together incorrectly, and I had to take them off and rebuild them each time. And I remember there was one Titan I rebuilt like 3 times because I kept doing it wrong. After the first Titan, I got the task flow down. So building 4 Titans, I learned how to build Titans correctly. That said, the Titans were inferior driving mechanisms, and I removed them all and put in Zesty Nimbles. Now, didn't he say in his email, he or she say in their email that they were going to use a specific extruder and a specific driver?
Yes. It says my Toolchanger is a BMG, using a BMG extruder with a Slice Engineering Mosquito, and then planning on using Prusa Slicer. Okay.
What is good, a good way to start is always with one extruder. I did all 4 all at once because all of my extruders are the same. Turned out to be the best approach. It's expensive, though. It costs quite a bit more because it's an expensive machine. And a lot of folks, their plan is you get one and you get different ones after that. There will be significant complications when your tools are all of different heights and different types. And keep that in mind. That will trip you up because I've seen folks who put in like a Hemera on one tool and the V6 in another tool, completely different height offsets, and you have to get those offsets down just right, and that could be a little bit on the tedious side. I have not had to deal with that because all 4 of my tools are V6s. I'm not sure about that particular extruder that you described, but the BMG driver we are very familiar with. I always recommend an original Bondtech and not the knockoffs. I've heard such bad reviews of the knockoffs. Some people find good knockoffs, some people find bad knockoffs. The problem is there's no way to know because they're not a name brand product. So when I need a quality extruder driver, I buy Bondtech. And it's worth the extra money. It's worth the extra money knowing I got the quality engineering and the support behind me. In fact, I saw a post on the iFactory board just the other day. Somebody used a clone BMG, and it totally broke apart while they were using it. It's a total failure. So I'm partial to only going with original equipment, both for the E3D and the Bondtech extruder driver. As far as the extruder that you described, I don't have enough experience with it. You're going to need some good cooling on it. I know that. I'm not so sure how well the heat rate works for PLA. Always wanted to test it. Maybe we'll get our hands on one so we can bang on it and test it.
Yeah, does it have an active cooling fan on it? I'm picturing it being very small with a good sized heat sink, but no active cooling.
Yeah, you can. There is an easy way to attach a smaller fan to it, but I think you can also put a duct with a 40 millimeter on it. I remember at Murph, I was looking at them, and after I left the counter, somebody kind of said to me, problems with that. And people mumbled to me about, I had a hard time with that thing. So that particular extruder, I would reserve judgment until I've tried it for myself. So it looks really cool, though. It's a beautiful extruder. It's a really nice design. There's no doubt you're going to need a good cooling capability for that heat break. But overall, the trickiest part of the Toolchanger is when you start to get to multiple tools working simultaneously. As a single tool at a time, it's a primo quality machine. I get the best quality prints with a single extruder from my Toolchanger, about equivalent to my Clone R1. They're both linear guides. They're both Core XY. The cantilevered bed on the Toolchanger is probably the best designed cantilever bed ever. You touch it and it doesn't move. It's super solid. So the challenges always come in when you start to do the multiple tools because of the offsets, because of the complexity in the slicer. You mentioned to me earlier that he's thinking about using Prusa slicer. A lot of folks, I know I'm going to get some negative emails on this, so this is my opinion. A lot of folks start with a Prusa Mark III. And I'm familiar with the Prusa slicer, and I understand you get comfortable with your slicer. You get comfortable with the labels of the different settings. You learn what the effect is going to be on the print from using that same slicer again and again and again.
Right. Irumbo is a Prusa owner, he tells us earlier. So,
yeah. And I heard this a lot from folks with that were used to using Cura as well. Now, I use Cura. I use IdeaMaker. I have used Prusa Slicer, and I have used a lot of the others. But I gotta say, for something as incredibly complex as the multi-tool Toolchanger, the best solution slicer-wise, in my opinion, is the now long in the tooth, have yet to be updated after years, Simplify 3D. And the reason for that is because of the multi-processes and the way it handles multiple tools. I've written a number of articles on the E3D forum about how to set up Simplify 3D. I agree that they've been neglectful about updating their software, but the Prusa slicer and the way Cura does it can't hold a candle to what I can do with Simplify 3D. Simplify 3D's true extreme high value is when you get into these kinds of complex 3D prints with multi-tools. That's where it's worth every penny. Now, unfortunately, they've gone fallow, and we haven't seen an update in a long time. And what I'm starting to suspect is they may have lost their talent. Like, they may have hired a couple programmers, and the programmers bailed, and so they don't have the skill sets to update any longer. That's a good possibility. Hope I'm wrong. I've heard that it was really all one individual guy and his mother does the business. I hope I'm wrong, and I hope they do update. It's a brilliant piece of software that needs an update, and I'd be happy to purchase a second license to get it updated. I would be happy to. It's that good a piece of software. Now, that said, I'm an uber hobbyist and a professional. A lot of folks out there with Ender 3s and ANETs and even Prusa Mark 3s, they're kind of like, I don't want to have to spend any money. I get the slicer for free, and it works great for me. I would warn you that you get into a jaded kind of a situation where you're so used to the settings in your particular slicer that you may miss out on the power and capabilities someplace else. And this is a good example of that. That said, I don't want to say anything negative about any of these other slicers, but Simplify 3D has things in it that no other slicer has. And if you don't know what I'm talking about, don't sling arrows at me unless you get it yourself and you start. If you've ever done a 3D print with 15 processes, you understand. You know what I'm talking about. And I've had to do that. I get 3 or 4 processes per tool, and I've got 4 tools. So it becomes incredibly complicated and hard to do, but it can't be done in any other slicer that I know of.
Yeah, on the diamond hot end, when I was blending colors and stuff, I was doing that all on Simplify 3D. And yeah, there was times when I had 15 processes going, because each process is a different color, and then you'd have different purge blocks for each one. And yeah, it was a lot of work, but yeah, there's stuff you can do with it you just can't do with anything else.
And if there's anything that's the gotcha on a Toolchanger, it's that. It's not that it's technically wrong. It's just that it's a complex thing to do, and there's just no easy solution to it. You've got multiple objects that need different tools, different colors, different materials, and you've got to program it correctly, and then you may need to set your settings different for different parts of the object with that particular tool, and that means multiple processes for that particular tool as well. And it does get complex. That's the gotcha. If that's too much for you, then I don't know what to tell you. That's multi-materials. It is what it is.
Well, it sounds like he's down for some complexity. I mean, if you wouldn't get into the Toolchanger if you weren't.
Yeah, it's about as advanced as we can get with open source based 3D printing. You can get a heck of a lot more advanced with industrial level 3D printing. I had a nice opportunity to sit down and get deep into the top of the line Mark Forged machine, and it made my head spin. It was amazing. I walked away thinking, how could I get one of these? And it's just too expensive for me. I think it was like a $50,000 machine. Oh boy, Whitney, another show written to the hard drive, waiting for encoding, uploading, and commitment on our feed to all of our very supportive listeners. Thank you all out there for your support on Patreon. Thank you for your positive reviews. And thanks for listening. We do it for you. We do it for fun. Still no advertising, although I got to admit, I've been getting the emails, and it's tempting, but no, we're not going to go there. Whitney and I don't need to. So we're not going to. We don't do this for eyeballs. We do it because we enjoy doing it, because it's fun. And I got a thing of the week. Speaking of fun.
Yeah.
I got a thing of the week. So I picked this for a couple reasons. We've seen lots of clips that hold things closed over the years. There was one shaped like a pumpkin, the famous one that looked like a shark. But this one This one's mechanical, and it works really, really well. It's called the Dino-Clip Mechanical Cam Chip Clip Print in Place. Thing number 5836815, which comes to us from a Thingiverse user whose handle is Sneaks. There's a Cheeks. Is Sneaks?
Sneaks is otherwise known as Brent H. from Detroit, Michigan.
Now, this thing, we've been talking about print in place for a couple of episodes now. What I really love about this thing is not only does it function really well, it does its job, but you could do a print in place without the fear of it not working right. I did not have to change anything in horizontal compensation in my slicer with this thing. And the reason for that is the joints are large and well contained. So even if you do get some overlap on a couple of layers, there's so much material there, so much plastic, that when you force the hinge to break open, the probability of it being a solid piece is really low. Unless your printer is really overshooting and way over extruding, this should be an easy print in place object. If you've never had the attempt at making a print in place, this is probably a good one to start with. And it uses a cam on a lever to keep the jaws tightly closed, and the jaws are shaped in such a way so that the object that's being crimped is well closed. So it's good for a chip bag. It's good for drawstrings on your sweats. It's good for anything that you use a mechanical clip for, and it does the job really, really well. And it looks really neat too.
Cool.
So let's see. If you've got a thing that you think should be thing of the week, or if you've got some suggestions or questions or just comments, what are you waiting for? Send us an email.
Send it to info@3dprintingtoday.com. That's THREE, the letter D, printingtoday.com.
We also invite you to join our community on Google Groups. Go to Google and search for 3D printing tips and tricks, and it'll take you there. And if you want to post, you have to hit that join button and give them an email, and then you can take part in the conversation. Lots of interesting things going on up there right now. Let's see. What's coming up on our show next week? Show number 385.
See, we start out talking about better belts.
We discuss how the Chinese